The Mesopotamians were the first astronomers to make long-term writing records of their observations.
Ziggurats were pyramid-like observatories built to watch movements of celestial bodies.
They came up with the idea of dividing a circle into minutes and seconds.
The Egyptians used astronomy for practical purposes,
such as developing calendars to predict floods,
as well as aligning temples to cardinal points.
The Stonehenge is comprised of roughly 100 massive stones in a circular layout.
Purpose of Stonehenge has remained a mystery, but in the 1960s, astronomer Gerald Hawkins suggested that it was an astronomical calendar, with points corresponding to astrological phenomena like solstice, equinoxes, and eclipse.
Chinese astronomers recorded observations of 900 solar eclipses and 600 lunar eclipses, meteor showers, exploding stars, and comets, including Halley's Comet.
Thales was a Malaysian astronomer who traveled Egypt to gather astronomical knowledge. He said that he predicted a total solar eclipse.
Pythagoras adopted the notion of a spherical Earth, developed a model for a solar system where celestial bodies moved in circular paths. The Earth revolves around a central fire every 24 hours.
Babylonians are able to use observations to see regularities and patterns in the motion of the moon and planets.
They believed in astrology, which involves the position of celestial beings and the influence on Earth.
Aristotle found that objects moving in a circular motion and celestial objects are spheres. The shadow of the Earth is circular, and some stars seen in some places can't be seen in others.
Aristarchus applied geometry to the study of astronomy. He used this equation to find the distance of the moon and sun.
Eratosthenes used geometry to calculate the size of Earth or the distance around the Earth.
Hipparchus discovered a new star in 134 BC. He also came up with the idea of precession, the slow circular motion of the north and south celestial poles among the stars.
The Mayans and Mesoamericans built monuments aligned to the position of sunrise and sunset and equinoxes and solstices. They also kept track of Venus's particular position in the sky, the risings of Venus, and lunar and solar eclipses. Ptolemy invented latitude and longitude and completed a system that could accurately account for the motions of the planets. He also proposed non-geocentric systems along with the movements of planets on epicycles and deferents.
Arabs and Muslims were the first to build observatories that were organized and equipped with instruments to measure positions of celestial objects.
Copernicus proposed the first fully developed heliocentric model of the solar system. It explained the moving position of constellations, the retrograde motion of other planets, Sidonic and sidereal period, also created the astronomical unit to determine planetary distances.
Brahe created a model between Ptolemy's and Copernicus's. The sun and moon orbited the Earth, and all other planets orbit the sun, so Earth is stationary. He also built astronomical instruments that were twice as accurate and carried out regular observations of the positions of the sun, moon, and other planets.
Shortly after the telescope was invented, Galileo observed remarkable phenomena. He conducted experiments with moving objects and paved way for terms like inertia, gravity, and other forces in physics. He observed that the moon had mountains, valleys, and plains, and that the sun was imperfect, with dark spots on its surface, and rotates every 4 weeks. He observed Jupiter and discovered 4 moons orbiting it, and also observed phases of Venus, which disproved the Ptolemaic model.
Newton formulated the law of inertia, law of force, and law of action-reaction. He investigated the nature of light and discovered the color spectrum. He developed a reflecting telescope, and he was the first to explain the tides scientifically.
Edmund Halley calculated the orbit of Halley's Comet. In 1716, he devised a method for calculating the planet Venus's transits across the disk of the sun. To calculate the Earth's distance from the sun, he timed the moon across the meridian, which he thought would be helpful with calculating longitude at sea.
Einstein's theory of relativity expanded on Newton's laws, mass and energy related to gravitational forces in space. In 1921, he won a Nobel Prize for his explanation of the photoelectric effect.
Niels Bohr worked on further expanding quantum theory in areas of quantum physics. He started basics of nuclear fission, or splitting of an atom, and also developed the model of the atom where electrons moved in fixed orbits.
Werner Heisenberg was the key pioneer of quantum mechanics. He made important contributions to the theories of turbulent flows, the atomic nucleus, ferromagnetism, cosmic rays, and subatomic particles. He also created the uncertainty principle.
Pauli was one of the pioneers of quantum physics, and he formulated the Pauli principle, which states that no two electrons in an atom have identical sets of quantum numbers.
Edwin Hubble played a crucial role in establishing the field of extragalactic astronomy. He discovered and proposed the idea of galaxies outside of our own. He classified all known nebulae. Hubble's law is that all galaxies recording from ours are proportionate velocities.
George Lemaitre is credited with the first definitive formula of expanding universe and the Big Bang Theory.
Robert Oppenheimer was the founding father of the School of Theoretical Physics. He was appointed scientific director of the Manhattan Project, building the atomic bomb.
Fred Hoyle is noted for his theory of stellar nucleosynthesis, as well as for his controversial stances, such as rejecting the Big Bang Theory. His theory was the panspermia, which is the origin of life on Earth, must have involved cells which arrived from space.
Penzias and Wilson discovered cosmic background microwave radiation, which backed up the Big Bang Theory. Cosmic background microwave radiation is the background noise of the universe caused by the residuals of the explosion. Wow. Neil Armstrong and Buzz Aldrin were astronauts aboard Apollo 11, the first space flight that landed humans on the moon in 1969.